say thanks for coming to listen to this presentation, which will be an introduction to Erlang in the context of real-time advertising auction. So first, a few words about me. My name is Philip Clark. Find me at that email address. I've been programming Erlang and working at AOL since 2012. And previous to this, I was doing mostly C++ development, some Python, and my main domain was in telecoms background. So within telecoms, the challenge there is to build very fault-tolerant systems that handle many concurrent events. So this domain has now moved into the internet, and the challenge there is to build scalable, fault-tolerant, highly concurrent applications. So it's no wonder that a lot of people these days are looking at Erlang to build server applications. What we will cover today is a very brief, very quick introduction to the language, just enough to get us to build a real-time auction system. And then we're actually going to visualize the concurrency using a web application that has D3JS and is connected to our Erlang VM via WebSocket. So what is Erlang, in case you haven't heard of it? It was a language developed at Ericsson during the 1980s with 3 researchers at Ericsson Labs. It got open source then in 1998, and multi-core support was added in 2009. So before 2009, when you run an Erlang program, your VM was using only 1 core on your system. After 2009, your Erlang program scales to utilize all cores in system without having any extra work to do for your program. So roll on approximately 30 years after Erlang was first conceived, and WhatsApp was sold for $19 billion. This raised a lot of publicity for Erlang, especially when people found out that there was only about a dozen developers in the back end developing the Erlang platform. So the main features of Erlang are that it runs many lightweight processes. These processes are not visible to the operating system that you're running on. They're processes running within the Erlang VM. The processes don't share memory at all, so they can only communicate with each other by doing message passing. The processes then are also very independent, and since they don't share memory, and since not everybody is a very good programmer, when bugs happen or a system misbehaves, we just let the processes crash. And that crash will be isolated only to a single process, and the rest of the system will run on as normal. So who is using Erlang today? Of course, Ericsson uses it, and they've built a telecoms platform reported to have 9 nines uptime. We've mentioned WhatsApp, or have their 500 million active monthly users. Oxcode have a product called Chef, which is used by the likes of Facebook and Google, and it's useful for managing thousands of servers and configuration for them. It's starting to become more popular for gaming platforms, such as League of Legends. If you use GitHub, then each time you make a request to GitHub, there's an Erlang proxy at the back end handling a request. AOL, of course, is using it for ad-serving platforms, but actually a lot of startups are ad-serving platforms, and they've also chosen to use Erlang. Klarna does a online payment system, thank you, and React is a very interesting distributed key-value data store. So we'll run in and get a quick overview of the language, but first of all, you have to be warned, if you're not familiar with functional programming, and if you're not familiar with Prolog, perhaps you won't be able to handle the syntax. Or maybe not within the first day of looking at it. But I will say that, a good programmer knows the differences between languages it's not really to do with the syntax, but it's the problems they solve. It's the programming paradigm that they use. So once you see how easy it is to build fault-tolerant concurrent systems with Erlang, you might even get to like this language. So there is some good news about syntax. It's a very small language, and you can learn it quite quickly. We have variables, but they don't vary, so don't worry about those. We don't have any loops to learn, no return statement, and while there is an if statement, I use that about once a year probably. So let's start with some coding. Work for us. So variables begin with capital letters, and they have single assignment. So if I have a variable called 1, I'm going to assign it to 1. And what single assignment means is, once I bind the value 1 to the variable 1, if I ever try to assign another value to 1, it's going to give me an exception error to tell me that 1 can never equal 2. Expressions then end in full stops. And multiple expressions get separated by commas. So if you're used to your C or JavaScript, yeah, maybe you like to end your lines with semicolons, and it can be a little bit disconcerting when it's a comma to end my first sub-expression, it's a comma to end my second sub-expression, but since my last expression that I have here is the last one, I ended in a full stop. So it's a little bit like trying to write English as well as writing a programming language. Processes then are the basic unit of concurrency. They are cheap to spawn, so in a system we try to have as many processes as we have events. So we have 1,000 events happening with 1,000 processes. They have their own stack and heap, so we're not sharing memory, and communication is done via asynchronous message passing. So even this Erlang shell here is a process. And if I type it myself, it gives me back this process identifier. If I want to send a message to the process, I give the process name or reference to it. I use the bind operator, and I can send it a hello world. And let's just end that with an OK. So let's send that in a few times. We've just sent a message to ourselves. The process then has a mailbox. So just like your email, the messages are sitting in there. So if I want to try and flush this mailbox, I can see that, yep, we got the hello world message several times. One nice thing about Erlang VM is it's very easy to introspect into what's going on. So let's say, for example, we start up graph here. This pretty picture is all the processes we have running in the Erlang VM at the moment. See if we can zoom in just a little bit better. So what you're seeing here is, I don't know if you can notice, some processes are red dots and some are blue dots. The only difference is that the ones with the blue dots are in the end processes. You can see a nice cluster of processes here at the front. They're all bound to a socket, which is started up by a web server, and all those processes are just sitting waiting to handle any request which comes into the system. So then we get to functions. So we don't need return statements in Erlang. When we write functions in Erlang, we always try to write for the specification and don't try to handle any type of error cases. So we'll see an example of that in a second. Functions can have different clauses. So in some languages, it's similar to overloading a method in a class. But in Erlang, there are different clauses for functions, and they pattern match against the arguments which come into them. Since we can't have loops and we can't increment index variables, we use recursion a lot when we're implementing the functions. So let's see, if someone told me to write a factorial function, I would ask them, okay, well, factorial of which numbers? And they might say, well, let's just do it for the first 3 numbers. So one of my favorite Erlang programs then is just to it's just to write a factorial function that does this. So the pattern matching works so that if somebody passes a 1 in, then it knows it's going to return 1. If someone passes 2 in, it's going to pass 2. So I'm going to check. Erlang also has this hot code loading. So in the background, my util module has just recompiled and it's already running in this Erlang VM. So where do I do factorial 3? I get 6. And if I do factorial 4, I just get an exception error. Now, if we noticed before, this Erlang shell was processed 2235. Let's see what happened here. So we're now running a different process. And this is how Erlang handles garbage in programming. If I put in 4, I didn't write the function for 4, and my process actually crashed. But my system is still up and running, and it works fine. So maybe you're thinking, okay, let's see what a real function looks like. One that takes variables. So if we do factorial n, okay. Now hopefully it's loaded and hopefully factorial 4 works. Okay. Not so much rocket science there, but you get the idea of functions now, I think. Lists are kind of interesting. Lists just store an arbitrary number of things. So Erlang's a dynamically typed language, and your list can store any different data type that you have. Internally, they're represented as linked lists, so we can't index very efficiently into a random part of the list. But what we can do is easily and efficiently remove the first item in a list. So quite often we use that to traverse a list. We write functions, and each time that a function recurses on itself, we take the first parameter off the list. So let's see what that is going to look like. So we have a list with just 4 items in it, and we can use this con cell. I'll write the syntax first. What the con cell does here is it will pattern match against this list. It will assign the h variable, which is the head of the list, to the value 1, and t, or the tail of the list, is the remainder of the list. So let's check. H is the value 1, and t, the tail of the list, is the remainder after you've taken 1 from the list. The actual list itself is immutable, so it will always stay 1, 2, 3, 4 for the lifetime of that process. So let's have a look at what we're going to build. We are going to build an auction system, a very simple one. So we will start off with one auction process. This auction process will communicate with clients. And it's up to the clients, if they want to bid, they can calculate the value and give it back to the auction. This is the kind of concurrency model we use in the production system. So if we got a request in for an ad, it would go into the auction process. The auction process would then spawn up these client processes. The client processes would then make HTTP requests to external demand partners to ask them, do they want to have an ad served, and if they do, what price are they willing to pay to have that ad served. We'll have an exchange process running as well, and that's going to create lots of concurrent auctions, and again, all those auctions will have their own clients. So let's go over the protocol, because we know that these auction processes and the client processes need to communicate via message passing. To start the auction, we'll start a timer, and then we will send to the client a message, which is a tuple, which will contain the auction process ID, and then an ID which identifies this particular auction. The clients in this case aren't going to communicate to any third parties, so all they're going to do is generate a random bid value. And then they want to communicate back to the auction process by sending their own client process ID and the auction ID, which is an indicator that they're in the correct auction, and the bid, which is going to be the bid value. The auction process will then eventually stop the timer and pick the bidder with the highest value. So, armed with our knowledge of message passing and processes, we can get started trying to write some code. Actually, I might need the next slide. So, hope that's okay to read. So this will be the client module. So we're going to have one module per process here. What happens in the client module is that it'll export this start function. It just sees the random number generator and calls handle bid request. When we get into handle bid request, we're going to sit and wait here to receive either this message, which is coming from the auction process, or after 10 seconds, we're just going to exit with a status of OK. If we get the message in, next thing we will do is call a function and send the bid response back. The bid value is just a random number generated from 1 to 5. And then we'll send this back to the auction process. Let's see if we can start up a client. If we do start up that client, let's see, can we manage to send it a bid request? So we're going to send it from ourself, which is this shell process. I'm just using auction identifier here, 1, 2, 3, 4, and this is going to be the first part of the system here, where we send the auction process ID and the auction ID. Just excuse me a second, I need my cheat sheet. I'll go on as well with me there. So what I did forget to do was actually spawn a new process for the client. Okay, so we spawned the client process using this spawn function. We got this client variable assigned, and we sent it a message. So hopefully, if the client program is working correctly, Yeah, we got a response back. The response was this tuple. It has the process ID of our client. It has our auction identifier, which is 1, 2, 3, 4. And we got a random value, which is the number 2. The auction process then itself will do a few things in a row here. First of all, it will call this function to spawn the clients. It will send bid requests to the clients. It's going to handle the bid responses then, and when they're all back, it will choose a winner. So we can have a quick look at the spawn clients. All it does is take in the number of clients, and it's going to spawn them up, and then recursively call itself until there's no more clients left. So this is loaded. Spawn clients, let's see if we can spawn 100 of these. And we know they should last for about 10 seconds. And if we're lucky, we might get to see them in Ruby. Actually, we don't see them spawned here because UbiGraph is connected to I wasn't meant to make the first error, so of course it's all. But, so we can spawn the clients anyway and see the process identifiers that come back from those. So we want to start sending some bid requests to the clients. So we seem to send a bid request to clients. We use the client process identifier, use the bind operator. We want to send it an auction ID. You've got to say that this is coming from the auction process. I'm going to send the auction ID in that message. So we know this function needs to take in an auction ID, and this function also needs to take in a list of clients. It's a recursive function. So we take in the first client, and we're sending a message to it, and the remainder of the clients get assigned to the clients variable. So once you send it to the first client, then we call again, send bid requests, an auction ID. We want to keep doing that until there are no more clients to send a request to. Once we finish sending the bid requests, we want to give ourselves an indication that we have finished. So if we say after 5 seconds, we are going to send to this auction process an indication that we've finished. See that is compiling with one error message because I didn't use this auction ID variable. If you don't use variables in Erlang, you can prefix them then with an underscore. And I'll get rid of that one. So what would be really nice is if we could spawn up the clients and then we can call this send bid request function to see will our clients actually respond back to us. So clients, auction, spawn, clients. Let's just take 10 for here. Call auction, send bid requests. And we have to give an auction ID. Let's just use 1, 2, 3, 4 for that. and we want to pass in the clients, the process identifiers for clients. Let's see how that goes. So we have this 5-second timer in our system, so which is long enough to get all the responses back. And if we do flush, we can see that yes, all the client process that respond did send us back the process ID, the auction ID identifier, and their bid value in there. Okay, so we got quite close to getting our auction system working. The next thing we've got to do is actually handle the responses. So when we're waiting to receive messages in Erlang, we use a receive statement. One message that we're kind of guaranteed to get is this finish message that we've sent to ourselves. So let's handle finished first of all. And what I'd like to do is send to my logger process. Actually, I won't do that. What I really wanted to do was just choose a winner. From everything that was in this auction ID, from the current responses that I get back. So I know this function now needs the auction ID and it needs the responses. So if a client does respond, it's sending us its process ID, so I just call it from. It's sending back the auction ID, and it's sending back its bid value. And if we get this, we'll call handle bid responses again with the auction ID, and we will save this bid onto all the responses that we currently have. And this is quite an interesting pattern match here, because we're going to call handle bid responses and we're going to specify the auction ID that should be used. This message that we receive here, though, comes from the client. So if the client sends us an incorrect auction ID here would be different than this auction ID. But we said variables only have single assignment. So sending in the wrong auction ID is not going to match this pattern match here, and handle bid responses won't ever be called. So we'll just put in another function clause just in case we get an incorrect auction ID back from the client. So we'll just ignore the auction ID and we'll ignore the bid. And in fact, we can just ignore who even sent us the response. And this time we'll call handle bid responses again, but we won't save that bid value. So this is more or less it. Choose winner is not defined yet, and the variable from is not used, so let's ignore that variable from now. So choose winner is going to have the auction ID, and it's going to have the responses back that I got from the clients. Now we're not guaranteeing that we're actually going to run any clients at all. So the first thing could be that there are no responses. If we get no responses back, I'd like to log that. I have this logger module. What it is just a function called loop. And loop sits there, waits to receive a message. When it's received the message, it does whatever it needs to do, and at the very end, just calls loop again. So that's just recursively running in its own process by itself. So we're going to send no winner to it if there was no winner of the auction, or we're going to send a winner when there was a winner of the auction. And those will just be displayed to the Erlang console. We'll also update our program so that whenever we get responses back from the clients, we'll either send a create or an update here, and that's going to send the information to the WebSocket for our web interface. So we're going to see that in a little minute. So first of all, let's finish this. We'll send you a logger. No winner in this case. And the auction ID. That was the specification. Yeah. Here, if we do get responses, then let's choose a winner. So, winner is what we've got to send back, the auction ID, and the value of that bidder. And that's just going to be the maximum value of all the integers we receive back. Okay, so I think we managed to do that without any syntax errors in it. One thing I want to do as well is whenever we get a bid in from a client, I'm going to notify the logger of this update. That I'm going to notify how many responses we have received so far. So it's going to be length of responses plus 1 on that. Okay, so some of the code up here, let's have a look at what this does. This init function just takes the number of clients that this auction wants to have. It creates a unique auction ID, which is just a timestamp we will use for that. It makes all the clients for us, so it spawns the clients. And then it glues together the whole send bid requests and handle bid responses functions. And then at the very top, this is the main API call. If somebody calls start and gives us a number of clients, this is where we actually spawn the auction process. Okay, so we could see does this work. We have that exchange process, which is creating the auctions. All it's doing is calling spawn link with the auction and the start function and giving the number of clients there. So it's not really doing very much. All the interesting work is in this auction module. So let's try just with one auction that doesn't have any clients. Okay, so it's looking good so far. This red dot here is just to indicate that there is one auction process running. Let's see if we can just put in one client in the auction. Okay. So when this one client responded, this bar grew right over to the end. If I make it 10,000, you can see it grow a little bit slower there. It's not really a real-time demo. The auctions are responding much faster than this. But there's a bit of a bottleneck because we have only one WebSocket open communicating with this web browser. So when we put in the 10,000, at least we can see slowly the progress and the order in which things happened here. So then if I go back to the console, we can see, yeah, the winning value for this process was 5. Took 5 seconds plus another 67 milliseconds there. So the additional latency actually is the time from getting a client request back to actually logging this out to the shell. So I think it's more interesting to maybe start up a few more auctions and a few more clients. So that is about 4,000 different processes running at a time. So each line is an auction, and each bar as it goes across shows the order in which responses come back. So one thing which is kind of interesting is if you look at the top line, this is the first auction spawned, and we know that the first thing an auction process does is spawn clients and send them a message. So, but by the time it finishes, we're actually about 70% complete already of the last auction spawned. And that's because Erlang does things concurrently very well. So even as we were spawning new clients here, it was spawning new auctions. And as we were receiving back the first client responses, all the other clients were almost ready to send responses back as well. So running everything concurrently like this sometimes isn't a good fit for your application. If you have a web server which is maybe just serving one static page, it's probably better you just handle the request, and send the response back. It's a bit like going in the fast food restaurant where you get into the queue and then you get served, you tell them your order, you take your burger, and you go away. And you want it done as fast as possible, and you don't want the people behind you to get served at the same time you're getting served. That's not what is happening here. Erlang, the VM, is trying to do everything concurrently. Modern web servers do a lot more now than handle static web pages. There's usually databases to be doing lookups on, and maybe other servers that you've got to send slow HTTP requests to. So in Erlang systems, usually you have lots of long-lived requests going on all at the same time. And by long-lived, I mean tens or hundreds of milliseconds. So Erlang, it's not like fast food, it's more like fine dining, where in a restaurant, all these processes are tables, and the CPUs in the system are the waiters. And so the waiter just goes around each table, gives someone a menu, gives someone else their starter, and gives someone else their bill. But the waiter never has to sit at one table while somebody finishes their dinner. So eventually everybody gets served, everybody has their meal, and everybody finishes. But we have to handle things concurrently like this. So one bad thing about this system is it's like, hey, look, everybody is taking 5 seconds to finish here. So it's not such a good program because even though all responses have been received, we're sitting and waiting to get this finish message before we actually finish. So what would be nice is if we actually keep track of the number of clients we have. So once we get 0 clients left, we're just going to go straight ahead and call choose winner. So just update these handle bid responses. So each time we get a valid bid back, we're going to reduce the number of clients by 1. So that's the invalid response, so the number of clients doesn't change there. Let's put the number of clients in that as well. So we'll take a quick look at this and see things happening a bit faster. And they are about 250 milliseconds for each auction. Now, another thing to look out for in concurrent frameworks is someone who tells you the framework is the next best concurrent thing, and they spawn lots of these lightweight workers, and the lightweight workers don't actually do any work. So really we didn't do any work here at all, except create a random number. So if you remember, we had our factorial program. So it was this recursive program. So when we know and we call factorial 500, let's check it's actually going to work. Yeah, it's just going to generate its extremely long number. But while it generates that number, it's going to use as much CPU as it can. It's not taking any break whatsoever while that happens. Let's see what this does to our auction times now. Did very little, did I save it? No, it should have an effect. Okay, so see this thing suddenly grinding to a halt here, but you know, what we didn't observe there was all the first clients hogging all the CPU, and then the next row of clients in the auction gets managed, and then the next row. When this comes back, you can see even the very bottom line there is making progress almost at the same rate as the client spawned at the very first. Okay, and now our auction time was what, about 2.7 seconds there. So the last thing that I didn't mention to you was that Erlang is very good for running a multi-core, but for this demonstration I set it up so that the Erlang VM would run a one core only. So I'm going to quit out of this VM. I'm going to run this demo again. This time the system's going to use all 8 cores on this hardware here. So anybody want to guess the speed up time going from 1 core to 8 cores? It's not 8, by the way. Let's put a number in your mind and just remember that, yeah, we are running a web browser quite heavily during this demonstration. There's also one little Erlang process that it's running there 100%, trying to flood the web browser with all these update messages as clients finish. And then I have a whole desktop operating system running at the same time. So this time you can see it's a lot more random as to the order in which clients run here, because we're not just running concurrently here. Some of these clients get to run in parallel on the different cores. And times, let's take a ballpark figure. There's 300, that was a quick one. There's 400, 492, 500. Let's say it's 500 milliseconds on average. So it was 2.7 seconds, it's 500 milliseconds. We got a speed up of 5.4, which, considering all the other things going on in the system, is not bad at all. So that was the real-time auction demonstrated. Final thoughts to you are, if you think you'd like to learn some Erlang, there's a great website, Learn You Some Erlang for Great Good. Take your time reading through it. It's good fun, and where I learned most of my Erlang from. And if you still think, no, I can't live with that syntax, have a look at Elixir. It's a different sort of style for writing Erlang code, but it does compile for the Erlang VM the same way as an Erlang program would compile. And it's definitely something to look out for in the future. So thanks for listening, everyone. I have that auction demo if you want to play with it up on GitHub. And I'm welcome to take any questions from you if you have them.
So you had in there, there was a couple of times where I saw the same kind of method declarations come up a couple of times. Is that how easy it is to do something like method, well, it's called clauses in Erlang. Is that how you do it, or is there anything more that you have to do to implement kind of method overloading in Erlang?
Yeah, no, that's it. It's a small language, and you know, we have this pattern matching idea, which, you know, let's add another clause for this. Let's say we want to handle all the auction IDs that have the value 1 in them. Then when we call handle bid response, if you don't call it with the first argument equal to 1, then you will never execute this clause here. It's going to drop down into the next one. So yeah, the clauses just end in semicolons, and this thing here, this is the whole handle bid responses function. It's just separate clauses for each individual part of it there. Okay, thanks very much for your attention, guys, and if anybody wants to chat afterwards, then feel free.